Welcome to this video. Today we will discuss some numerical problems related to transistor biasing. So the question is displayed here. So you have to design a voltage divider circuit for a silicon transistor with HFE equal to 100 and S less than or equal to 8. The Q point is given, VC equal to 5 volt and IC is 1 milliampere. The source voltage is 10 volt and the resistance RE is 1 kilo. So first we can draw the circuit diagram. So there is a potential divider on the input side. Then you have a transistor in common emitter configuration. So this terminal is grounded. You have source voltage here, VCC. So this is RC. This resistance is RE. This is R2. This is R1. So if you read the question, you can see that RE value is given 1 kilo. RC, R1, R2 you have to calculate. So to complete the design, we need the value of these three resistors. So here it is written as HFE is equal to 100. So HFE is another terminology used to represent beta of the transistor. So beta is 100. So we will see what is HFE in details when we study H parameters. So beta is 100 for this transistor, and in the limiting case, stability factor is S. Stability factor is less than or equal to 8. So we can design the circuit for the limiting case. So S is 8. So we know the formula for S. S is beta plus 1 into 1 plus RTH by RE divided by beta plus 1 plus RTH by RE. This we have derived earlier. So you can substitute the values. S is 8, beta plus 1, beta is 100, so this is 101 into 1 plus RTH is unknown and RE is 1 kilo ohm. In the denominator also, beta plus 1, it is 101, RTH is unknown, RE is 1 kilo ohm. So you have one equation with one unknown. RTH is the only unknown value. If you solve this equation, you will get the value of RTH. So RTH is 7.6 kilo ohms. Okay, so you can solve it and check the value. RTH is 7.6 kilo ohm. So RTH is nothing but R1 parallel R2. So R1 R2 by R1 plus R2 is 7.6 kilo ohm. So this is our equation number 1. So we have two unknown values, R1 and R2. So to solve this, we need one more equation. So that can be obtained by replacing this potential divider by its Thevenin equivalent. So we can do that. So if you replace the potential divider by its Thevenin equivalent, you will get a circuit like this. Potential divider is replaced by an ideal voltage source VTH in series with RTH. The remaining part of the circuit is same. Okay, so the current flowing through RTH is IB and current flowing through RE is IE. And we can apply KVL in this loop. So if you apply KVL, you can write VTH source voltage is equal to drop across RTH, that is IB into RTH, plus drop across the base emitter terminals, that is VBE, plus drop across RE, that is IE into RE. Now one more simplification is possible. You can replace IB in terms of IE in terms of IB. IE is IC plus IB. IC is beta IB, so beta IB plus IB, so you will get beta plus 1 into IB for IE. So you can replace here beta plus 1 into IB into RE. Now we need the value of IB to simplify this. So IC is given in the question. So if you read the question, you can see operating point is given. IC is 1 milliampere. So IB you can calculate. IC is 1 milliampere. So IB is IC by beta. So 1 milliampere divided by 100. So it is 0.01 milliampere. So you can substitute it here, 0.01 milliampere into RTH. We got the first equation, 7.6 kilo ohm. So 7.6 plus VBE. So in the question it is given as it is a silicon transistor. So VBE is typically 0.6 or 0.7. We can take 0.7 volt. Then beta plus 1 is 101. IB is 0.01 milliampere. RE is 1 kilo ohm. So please remember that I have substituted the currents in milliamperes and resistances in kilo ohm. So the answer will be in volt. So if you simplify this, you will get 1.686 volt. So VTH, we know another expression for VTH. VTH is VCC into R2 by R1 plus R2. So that is 1.686 volt. So that is our equation 2. So if you divide equation 1 by equation 2, so let me copy equation 1. So if you divide equation 1 by equation 2, this R2 by R1 plus R2 term will cancel. So you will get R1 divided by VCC is equal to 7.6 divided by 1.686. This 7.686 is in kilo ohm. So your answer will be in kilo ohm. 1.686 is volt. VCC is 10 volt. So R1 is 7.6 into 10 divided by 1.686. So if you do the simplification, you will get R1 as 45 kilo ohm. So you can check the answer. It is 45.0408 kilo ohm. So approximately 45 kilo ohm. That is the value of R1. Now R1 into R2 by R1 plus R2 is 7.6 kilo ohm, and you got the value of R1. So substitute it here. So you will get the value of R2. So you can do it. So if you substitute 45 here, it is 45 R2 divided by 45 plus R2 equal to 7.6. So you solve for R2 and you will get R2 as 9.14 kilo ohms. Okay. So we got R1 from here and you substitute back the value of R1 in equation 1, you will get the value of R2. So we solved for R1 and R2. So these two resistance are now available. R1 is 45 kilo ohm and R2 is 9.14 kilo ohm. Okay. Now we have to calculate RC. So how to calculate RC? So to calculate the value of RC, you need the voltage drop across RC and the current flowing through RC. Then you can apply Ohm's law. So what will be the voltage drop across RC? So on the output side, you have this arrangement. Supply voltage is VCC, this resistance is RC, and you have VCE is the potential drop across collector emitter terminals, and this is RE. So if you apply KVL on the output path, you will get VCC is equal to drop across RC is ICRC plus drop across collector emitter terminals VCE plus drop across RE is IERE. We know the value of VCC, it is 10 volt, IC is 1 milliampere, RC is unknown, VCE is given in the question. So let us go back to the question. VCE is 5 volt. So 5 plus IERE. IE is also available. We have calculated the value of IE. So IE is beta plus 1 into IB, that is 101 into 0.01 milliampere. So it is 1.01. 1.01 milliampere into 1. So if you simplify this, you will get the value of RC. So do the simplification, you can see that RC value will be 3.99 kilo ohms. So we got all the values of the components in the circuit, R1, R2 and RC. RC is 3.99 kilo ohm. So that completes the design. So let us go to the second question. So here you have to design a voltage divider bias circuit and some values are given. Ratio of base current to current through RB2 is actually R2. R2 is 1:10, and the source voltage is given, beta is given, and VC is 50% of VCC. So we can evaluate these values. VC is 50% of VCC. You can pause the video and copy the question. So 50% of VCC, that is 0.5 into 22. So it is 11 volt. Voltage drop across RE is 10% of VCC. So 10% of VCC. So it is 0.1 into 22. So it is 2.2 volt. And voltage drop across RC, that we can calculate. So from the previous problem also we know that sum of these three values is equal to VCC. This is the output side. So VCC is actually sum of VRC plus VCE plus VRE. Okay, voltage drop across RC plus VCE plus RE gives the supply voltage. So supply voltage minus these two values, you will get the value of RC. Or you can do it in another way. VC is 50% of VCC, VRE is 10% of VCC. So 50% is dropped here, 10% is dropped here. So remaining 40% will be dropped across RC. That is also okay. So you can write 40% of VCC. So if you do that 0.4 into 22, you will get 8.8 volt. So if you do like this also you will get 8.8 volt. Okay, either way you will get the value of VRC. So once you get the value of VRC, you can easily find RC, because if you apply Ohm's law across the resistance RC, voltage drop across RC is VRC and current flowing through RC is IC. So RC is nothing but voltage across that divided by current flowing through the resistance. Voltage across the resistance, we got the value VRC is 8.8 volt. 8.8 volt. Okay, so 8.8 volt divided by IC is 0.8 milliampere. IC is 0.8 milliampere. So 8.8 volt divided by 0.8 milliampere. So you will get 11 kilo ohms. So that is the value of RC. Okay, now we can calculate the remaining values. Since IC is 0.8 milliampere, we can calculate IB. IB is IC by beta. So IC is 0.8 milliampere, and in the question beta value is given. So beta is 100. So you will get the value of IB as 0.008 milliampere or 8 microampere. Okay, so now you can calculate IE. IE is IB plus IC. So IB is 0.008 milliampere plus IC is 0.8 milliampere. So you'll get 0.808 milliampere. So what will be RE? RE is voltage drop across RE divided by current flowing through RE, that is IE. VRE is 10% of VCC divided by IE. 10% of VCC we have calculated, we got it as 2.2 volt divided by IE. IE is 0.808 milliampere. So you will get the value of RE. RE is around 2.72 kilo ohm. So you can check it. So we got both RC and RE. Now we have to calculate the values of the potential divider, R1 and R2. Okay. So let me redraw the circuit and get a relationship between voltage across R1 and voltage across R2. This is voltage across R1, this is voltage across R2. This is VCC. So you can easily see that VR1 plus VR2 is VCC. That is one expression, one equation. Then you can also see that if you apply KVL in this loop, you can see that VR2 will be equal to VBE. This is plus 2 minus, this is also plus 2 minus VRE. So VR2 will be equal to VBE plus VRE. That is another relation. VR2, voltage across R2 will be VBE plus VRE. So VBE is 0.7 volt or 0.6 volt. If it is specified in the question, you can use 0.6, or if it is not given, sometimes in the question it will be specified. So here nothing is specified, we can take it as 0.7. VRE is, what is the value of VRE? VRE is 10% of VCC. So that is 2.2 volt. Okay, so 2.2 plus 0.7, so it is 2.9 volt. Now to calculate R2, what you need, VR2 divided by current through R2. Suppose the current through R2 is I2. Suppose this is the current I2, and current, suppose current through R1 is I1. So we need the value of I2. So what is I2? In the question, if you go to the question, you can see that ratio of base current to the current through R2 is 1:10. So ratio of base current to current through R2 is 1:10. So I2 is 10 times IB. So VR2 is 2.9 volt divided by 10 times IB. IB is 8 microampere. So if you do the simplification, you will get the value of R2. So that value is 36.25 kilo ohm. So you can check it. Then we need R1. R1 is voltage across R1 divided by current flowing through R1. So what is the voltage across R1? You can use this relation. VR1 plus VR2 is VCC. So this is VCC minus VR2 divided by I1. VCC is 22 volt. VR2 is 2.9 volt. 22 minus 2.9 divided by I1. What is I1? You apply KCL at this point. So I1 is equal to sum of these two currents, I2 plus IB. And I2 is 10 IB. So 10 IB plus IB, it is 11 IB. So you can substitute 11 into IB here. So IB is 8 microampere. So if you do the calculation, you will get R1 as 217.05 kilo ohms. Okay, so that is the value of R1, and 36.25 is the value of R2. So we got all the four resistors, R1, R2, RC and RE. Okay, so that completes the design.